Kim Hackett is the authority engineer for Silicon Valley Clean Water, the wastewater utility serving cities of Belmont, San Carlos, Redwood City, as well as the communities served by West Bay Sanitary, Menlo Park, and I think some of East Palo Alto. But anyway, she's been doing this for 20 years. Looking pretty young, Kim. So 20 years of experience in the wastewater field, has been with Silicon Valley Clean Water for 11, and manages as the authority engineer, which I have to say is the best title I've heard in a long time. It's a joint power authority. So anyway, she manages the engineering, environmental services, and lab divisions of Silicon Valley Clean Water, and as well as the capital improvement program, and it's been RESCU, regional environmental sewer conveyance upgrade, and the programs around that. So a lot of stuff going on. I'll let you get to a description of it.
Thanks very much. Thanks everybody for having me.
will, yes, you grab the screen.
All right, let me grab the screen. Okay, very good. Thank you. So I'm here to talk about big infrastructure and the projects that we are doing at Silicon Valley Clean Water in support of our capital improvement program. There it is. So really quickly, this is the boundary, our service area for Silicon Valley Clean Water. We are the conveyance and treatment utility. So each of our member agencies has their own sewer collection system. They deliver the sewage to us at one of our many pump stations, which is conveyed to our treatment plant, which is at the end of Redwood Shores, where it's treated and either discharged into the bay or returned to the city of Redwood City for recycling. The treatment plant was built when construction began in 1978. Like many treatment plants were built in the 70s due to the Clean Water Act requirements. And in the case of what was then South Bayside System Authority, we had a bit of a branding change 5 or 6 years ago. Our member agencies, who each had their own treatment plants, decided to come together and build a regional treatment plant and form this joint powers authority in order to meet the new Clean Water Act requirements. The construction project, again, like many wastewater treatment plants in the 70s, was grant funded from grants from the federal government, which must have been nice. And then so since then, for the next 30 years, it was operated and maintained extremely well, but with very few capital dollars put into the project. So we found ourselves in 2008 with aging equipment that was 30 years old and kind of falling apart, aging electrical system, and underwent this CIP, capital improvement program, in order to try to rehabilitate the plant and continue to maintain our NPDES permit requirements. So we had several goals for the CIP. The first I mentioned, rehab and replacement of aging equipment. We've got a couple of photos there that show the concrete deterioration that occurs when concrete is in the presence of the gases that come off of wastewater. So you can see on that bottom picture, the concrete is showing rebar, which is also now corroding. Another focus of the CIP was to automate our processes and process by process put in the instruments and the actuators and the equipment needed that the plant could run itself more and didn't need as much direct operator intervention on a day-to-day basis. Energy efficiency and electricity production. One of the things that we produce as part of our process is methane gas, which we collect and burn to provide electricity to the treatment plant. We also have a bank of Tesla batteries to help even out our daily electrical loads. And every project is certainly focused on energy efficiency as well. And the last, and it was last for a reason, the last element of our CIP is the conveyance system upgrade. And the reason that it's last is these are the most expensive projects as part of our CIP, and our member agencies asked, as we were undergoing this CIP in 2008, could we push the expensive projects to the end so they could raise their rates gradually in order to be able to meet the capital needs that we would have as part of the conveyance system. So I'm going to talk, the majority of this is going to be about our conveyance system upgrade, which our clever acronym is RESCU, Regional Environmental Sewer Conveyance Upgrade Program. And we developed this program based on failing infrastructure. The force main was even older than the treatment plant, and we were operating it at pressures that it was not designed to withstand. We were experiencing expensive repairs every year. We were sending operators up and down the entire length of our force main every 2 weeks to look for evidence of force main leaks. And we recognized that, you know, we had a real old infrastructure that needed replacement or rehabilitation. Another interesting thing about the treatment plant is that it was built without a headworks. Most wastewater treatment plants have a headworks with screens and grit removal in order to protect the processes from some of the big solids or some of the grittier sandy solids that can really kind of destroy pumps and valves. So there were 3 major projects in our rescue program. The first is the front of plant project, which is the headworks that I was just talking about, as well as a very deep lift station that pulls the sewage out of the sewer and up into our treatment processes. The second is the gravity pipeline project, which is our tunnel project that was featured during the break. It goes under everything except for Marine World. And the third is our pump stations project, which addresses our 5 pump stations that we had in the service area, rehab and replace. So I'm going to start showing a lot of construction. I hope you guys like construction photos because I do, and I've got a lot of them. So this is the front of plant project. This is our headworks and our very deep lift station. These are from kind of early on in the construction when we were just doing kind of the structural work, the concrete, digging the shaft needed for the receiving lift station. And this is current construction. I think this picture was taken about a month ago. And if you can see, there's a kind of a small circle and a large circle. The small circle is our flow splitter shaft, where it serves 2 purposes. The first is it's where we took the tunnel boring machine out when it was done with the tunnel project. But in the future, it's going to be to split and condition the wastewater flow coming into the pump station. The bigger circle here is the pump station, the receiving lift station itself. And then the flow goes into the headworks structure, which has our screens, grit removal, odor control for the entire system, and electrical building. A couple more photos of the front of plant project. The photo on the left is the discharge piping for the pumps coming from the RLS and then up onto the headwork structure. And the one on the right is looking down into the receiving lift station at the piping manifold that's being installed. Pump stations improvement project is another one of our projects in rescue. For that project, we're rehabilitating one of our pump stations, basically pulling out every everything, every mechanical and electrical element, and replacing the roof. And we were able to do that on that site, just rehabilitate it rather than replace it. The bottom that's our Redwood City pump station. And unfortunately, the existing structure is too small. And so we are building a new pump station on the same site, right next to the existing pump station, and keeping the existing pump station in service until the new one is complete. And then the photo on the left is we are building a gravity sewer to flow the majority of flow, to have all of the flow from our Belmont service area flow by gravity into the tunnel system, which saves us reduces the need for the Belmont pump station. And that's a micro tunneling project going down Shoreway in Belmont and San Carlos. And I'll just take a second to say we are so thankful for the businesses along Shoreway that we are disrupting. And we appreciate their patience, including Linkso, sponsor of this event, who you can buy all of your outdoor water feature supplies except for fish. They are open during construction, so please continue to go to Linkso. And then the big one, of course, is the gravity pipeline project. That's our tunnel. It's 3.3 miles long, 16-foot diameter on the outside, with an 11-foot diameter sewer inside of it. And it's built using an earth pressure balanced tunnel boring machine that was constructed and in Germany by a company called Heron Connect. The picture on the left is from Germany, when the project team went out to go inspect the construction. It was designed, built, put together, tested in Germany, and then taken apart and shipped over to us, where we put it back together, tested it, and then before putting it in the ground. So it's 16-foot diameter. It's over 600 feet long with all of the supporting gantries behind it. It cost us 10.8 euros, and we did get a discount for paying for it in euros. And it was named, it's tradition in tunneling projects to name your tunnel boring machine, and it's always a female name. And so the name of our TBM was Salus, who is the Roman goddess of safety and welfare. These are some pictures from our launch shaft site. The picture on the left is the shaft that was constructed in order to put the tunnel boring machine into the ground and begin the tunneling process. The picture on the top right is the line of gantries staged above ground before they were put in the ground behind the tunnel boring machine. And the picture on the bottom is the segments that went together to make the circumference of the tunnel. The tunnel boring machine bores itself forward and puts these segments in place behind it in order to support the tunnel excavation. More pictures. This is on the left is the gantry, the very last gantry looking behind at some of the segments being delivered. And as you can see, they put down rail tracks, and they had an electric locomotive bringing equipment and materials and people back and forth between the surface and the tunnel boring machine. And the right is just a screenshot of the controls system that they had. They could tell you exactly where the tunnel boring machine was at any given time, what pressures it was facing, what pressures it was exerting, more information than I ever knew what to do with, but we had some very smart people looking at that TBM at all times. And then some pictures from the successful TBM removal. So a few months ago, we did break through into the final receiving shaft. That's the picture on the left. It had to be under we had to fill the receiving shaft actually with soil and water in order to have the pressures be good for tunneling through the wall of the shaft. Right now, in that picture, they're excavating around the tunnel boring machine. And then the other two pictures are just of the TBM as it was being pulled out and disassembled, and then sent off to its next tunneling project. I want to talk a little bit about funding. I mentioned that the original treatment plant project was grant funded. Grants are pretty hard to come by these days, but we did avail ourselves of some low interest loans, both from the EPA, the WIFIA, Water Infrastructure Finance and Innovation Act loan, and then also a state revolving fund loan that really reduced the amount of the payments that will need to be made over the next 30 years in order to fund these projects. That picture, that's Michael Regan, if you may recognize him as the EPA administrator. He came to our site to announce the granting us of the one of our WIFIA loans. So that was kind of a big moment for me. And then I want to address, before I'm done, in listening to all of the innovative things that are being thought about and being done in the Bay Area and specifically in Silicon Valley for water, I feel like the kind of a dinosaur, more concrete, more pumps, bigger pipes, and I think that that's okay. I think that wastewater treatment plants and specifically regional wastewater plants were built on purpose. It was and over the last 50 years, these large and small wastewater treatment plants throughout the region have dramatically improved the water quality and drastically reduced the non-point water pollution that was going into our water bodies. Will they be the solution in 50 years from now? I don't know. But they are still the workhorses of keeping the Bay clean. And I think they can be part of the solution as well, along with the satellite treatment, along with the on-site treatment, along with water conservation and all of the other measures. I just want to say, let's not forget about the big old dinosaurs that are the wastewater treatment plants, because they are falling apart and they do need attention and they do need funding in order to continue to meet our needs. So with that, I am happy to take any questions.
Thank you very much, Kim, for the report. I would certainly agree on the all of the above strategy, because basically the primary treatment plants are just a major component of this, and in terms of the everything flowing to the Bay and the NDPS structure. Obviously, workhorse is a good description. I did see actually it went away. I did see a raised hand, but we don't have any questions. I did actually, this is just a kind of a factual question. You mentioned in terms of the tunnel itself, and there were some really great pictures there that, I was trying to get a sense of the size and, just like the diameter of this, because there's 3 tunnels, right? Or is it one bore and then?
It was 2. So we,
2 bores.
Yeah, I don't think I've got a good figure that shows the map, but we went in 2 different directions. From our launch shaft, we went underneath the San Carlos Airport towards Inner Bear Island. That was our first bore. And then we took the TBM out of the ground, brought it back to the shaft, which is near the San Carlos Airport, put it back in the shaft, and then sent it down underneath Redwood Shores Parkway toward the treatment plant. So it was the same boring machine used in 2 different bores.
And I do have, I don't know if we did this particular poll, so I'm going to go to it. No, let's see. Okay, I'm launching this question. I hope, can you see it?
Yeah.
Okay, so yeah, so the tunnel boring machine, or the earth pressure balance machine, which is even a better name, has been used in some very high profile things in addition to Silicon Valley clean water. And so these are some of the possible options as well. And so we'll just let this run for another 30 seconds just to do a quick one there. And you know, we wanted to use polling this time around, and it seems like, Kim, you remembered a few of them actually, which was great to hear quoted. So it's pretty okay. So we're going to end at 1 minute, but the answer, and we should have put it in as an option, I forgot to do that, was all of the above. And so yes, it was the Channel and San Francisco subway, as well as I guess in London, the Thames water ring. So actually, yeah, that tunnel boring machine or technology like it has been around. So apologies for me for not including the all of the above option on that. So everybody's a winner. Kim, actually, one question is, as of today, well, what lies ahead for you?
So we are about a year away from the tunnel project being totally complete, as well as the front of plant project. The tunneling part of the tunnel project is done, but now we're working on installing the sewer pipeline within the tunnel, and that should be done in the August timeframe of 2022. And the headworks and front of plant project is on the same timeline. The pump station projects are about a year after that, so summer 2023. So we're in the home stretch.
Mm-hmm. Yeah, no, it's I'll definitely be keeping an eye on this, and I know you know, on a lot of this stuff, the people at Tanner Pacific have you know, been involved quite a bit as well. I saw, like, on their website today, the old Radio Road building was
yeah, they do all the construction management for our capital projects, and they're also providing project management services for the tunnel project. So, and their office buildings are right next to our treatment plant, so that makes
yeah,
it easy.
So it's yeah, well, apparently there's yeah, still much to do, but as you say, home stretch, it's going to be quite an upgrade. As you mentioned, it might, you know, be a 50-year, you know, I guess, well, what is your expectation, say at the end of 2023, in terms of usable life? I suppose that's more involving the pumping stations rather than tunnels.
Yeah, we expect the tunnel to we actually required a 100-year design life for the tunnel. It's not, you know, there aren't any moving parts. It's expected to have a very long life. The pumping typical pumping systems, 30 years, 20 years for the electrical. So we're already planning, we're already replacing things that we were constructing at the beginning of our CIP back in 2009, 2010, and it's going to be a more steady progression of capital improvements rather than we're not going to wait 30 years and then have to sell a lot of bonds to do a lot of projects at 30 years from now.
Yeah, well, okay. Well, great. Well, thanks once again for showing us all this. And it seems like there's even more victory dances ahead.
Thanks very much. Thanks, everybody.